All right, here we go. Let's start solving absolute value equations. We're in section 1.4 today. So the absolute value, I know you've seen this in pre-algebra. This is just a recap, but maybe solving absolute value equations is new. So absolute value is the distance a number is from zero. So if we look at a number line, absolute values say how far a number is from zero. So if we look at this number here, and I'm looking, let's say, at the number 4. 4 is 4 units away from zero. How many units away from zero is negative 6? 6, exactly. Absolute value determines a distance a number is from zero. Distance is always positive. So when you have an absolute value functions always take it and turn it into a positive number. So this here, the absolute value of 5 reads as how many distance from zero is 5, and the answer is 5. This, when you see like straight lines like this with x in between, that means the absolute value of x. It's on your calculators. There's a function that does it for you, but basically all you would need to know is take any number and make it positive, and that would be its absolute value. So absolute value equations, though, are what we're learning today in this section. Absolute value equations can have one solution, two solutions, or no solution. So we're going to be solving equations just like we've been solving. On Thursday of last week, we had a quiz on solving multiple step equations with variables on both sides. And today we're still continuing that, but now we're going to be solving absolute value equations. So this equation here says the absolute value of x is equal to 10. When we have absolute value equations, I'll do the work on the side here. You basically split the equation up into two separate equations because absolute value tells the distance, and there's always going to be two numbers that are 10 units from zero. And that's because negative 10 and positive 10 are both 10 units from zero. So basically what you do is you split it up into two separate equations, drop the absolute value bars. The first equation looks exactly like that one without the absolute value bars. Please write that down. A lot of you are staring out into space. So the first equation we have is the absolute value is equal to 10. The second equation that we have is the absolute value is going to be equal to the opposite of 10. So we have x is equal to negative 10. So when you have absolute value equations, to solve them, you split them up into two separate equations. The first one looks exactly like it does with the absolute value bars. You just take them away. The second, you change that number into its opposite, negative 10. And that's because negative 10 and positive 10 are both 10 units away from zero. So if we look at this is 10 units from negative 10 to 0, and from 0 to 10 is also 10 units. So the two possible values for x are negative 10 and positive 10. That's because both of these numbers are 10 units away from 0. That one's pretty easy because it's just the absolute value of x. Example 2 is a little bit more difficult because it says the absolute value of x minus 4 is equal to 6. So you'd have to figure out what two numbers, when you take 4 away, the absolute value of that would equal 6. So some of you might have that positive number in your head and already know, like, okay, I know what number minus 4 would equal 6. But then the other one is what number minus 4 would equal negative 6, which is sometimes harder. So here's what you do. You split it up into two equations. The first equation will be x minus 4 equals 6. So make sure to write that down. The second equation is still going to be x minus 4, but we want the middle stuff to not equal 6 this time. We want it to be equal to negative 6. Because the absolute value of negative 6 is also equal to 6. So whatever the middle stuff is, if it's equal to a negative 6, it's going to spit out and become a positive 6 because of the absolute value function. So the two numbers that this could be are either 10, so if we solve this one, we would add 4 to both sides. And in my mind, I already knew 10 was one of the answers because I was like, okay, well 10 minus 4 is 6, the absolute value of 6 is 6. But the second one is the harder one to find. When you go to solve this one, I wouldn't really think of this one, but this will still work. When you add 4 to both sides of this side, negative 6 plus 4 is negative 2. And negative 2 minus 4 is negative 6, and the absolute value of negative 6 is still 6. So you get two answers. So I need to scroll down. It says the two possible values for x are 10 and negative 2. So 10 and negative 2. In any order, you don't have to put it in a certain order. It can be negative 2 and 10. That works. Okay, any questions so far? All right, if I clear this stuff out and scroll down, we have another example. The example says the absolute value of 3x plus 12 equals 0. So the first thing when we're solving these equations is we split them up into just equations without the absolute value bars. But this one's interesting because when I go to split this up into the two equations, 3x plus 12 equals 0, the second equation would be 3x plus 12 equals negative 0. And that doesn't make any sense because 0 can't be negative. So this one's only going to actually have one solution. So when I go to solve this one, I would subtract both sides by 12. I get 3x is equal to negative 12. And I divide both sides by 3. I'm going to get x is equal to negative 4. So this one only has one solution. And this will happen every time the absolute value is equal to 0. So the possible values for x are just negative 4. There is no second solution. And you can always check to make sure that this works by taking your answer and putting it in for x. So if I do 3 times negative 4, that's negative 12. Negative 12 plus 12 is 0, and the absolute value of 0 is 0. So I know that it works. All right, the last thing we need to learn before we can start trying some practice problems is when c is less than 0, the absolute value equation has no solutions because an absolute value can never equal a negative. For example, the absolute value of 3x plus 1 equals negative 5 is impossible. It's impossible because an absolute value can never equal a negative number. If I make it simpler, like the absolute value of x equals negative 2, this is also impossible. An absolute value number can never equal negative because absolute value takes every number and turns it into a positive. So this is considered no solution. Whenever you have a situation where it's impossible when solving equations, we call the answer no solution. There's no solution because you can never have the absolute value equal a negative number when it's in place like that. Okay, any questions? All right, flip this over. We have 2 more practice problems before I'm going to have you guys try some on your own. So before you can solve equations, you have to isolate the absolute value bars. That means that when you go to solve these, there can be nothing added, subtracted, multiplied, or divided outside of the absolute value. So this says the absolute value of 3x plus 9 minus 10 equals negative 4. I need to get rid of that minus 10 before I can do anything. So the first thing I'm going to do is isolate the absolute value bars, which means get these by itself. To do that, I have to add 10 to both sides. When I add 10 to both sides, these cancel out. I'm left with the absolute value of 3x plus 9 equals negative 4 plus 10 is 6. Now this equation is isolated. The absolute value bars are by itself. We cannot touch the 3x or the 9 until we get rid of the absolute value bars. When we go to solve this equation, we split it up into 2 separate equations. The first one looks exactly like this, just take away the absolute value bars. So it's going to be 3x plus 9 equals 6. This second equation is going to look very similar, but instead of it being equal to 6, we change it to the opposite of that, and it's going to be 3x plus 9 equals negative 6. A lot of kids wonder, well, I thought that we can never have a negative number as an answer. Well, notice the absolute value bars disappear when I go to solve them. So the reason why I can still do this is because there is no absolute value around this anymore. what we're doing basically is trying to find what number is equal to 6, since the absolute value of 6 equals 6, and what number this could equal, so this would be negative 6, since the absolute value of negative 6 is also 6. There's usually 2 answers to each one of these problems. To solve this, I'm going to do the same 2 steps. The first thing I'm going to do is subtract 9 from both sides. I get 3x is equal to negative 3 on this side. I divide by 3. And I get x equals negative 1 for one of my solutions. How can I double check to make sure that this answer works? Plug it in. So if I take negative 1 and I put it in for x here, 3 times negative 1 is negative 3. Negative 3 plus 9 is 6. The absolute value of 6 is 6. That one works. If I do the same 2 steps here, subtract 9 from both sides, I get 3x equals negative 15. And I divide by 3, I get x equals negative 5 as my second answer. And again, if I do this and I plug it in, 3 times negative 5 is negative 15. Negative 15 plus 9 is negative 6. The absolute value of negative 6 is positive 6. We're going to try one more together. Letter B. This one says 4 times the absolute value of 2x plus 7 equals 16. Don't get confused with this type of problem and think it looks like this. This does look very similar. And in this problem, what would be the first thing you would do?
Divide.
You could divide? What did I teach you to do? Distribute. This is different than this, though. What's the main difference you see with the little grouping symbols? Yes, these are curved. These are parentheses. And what we're doing right now are absolute value bars. And unfortunately, you are not able to distribute inside of absolute value bars. So you can't do 4 times 2x and 4 times 7. So exactly what Gavin said is what we will have to do. To get rid of the times 4 here, we have to divide by 4. We will not be able to distribute on the inside. So to get rid of that 4 on the outside, we'll have to divide by 4. When I do that, I'm left with the absolute value of 2x plus 7 equals 4. Now the absolute value bars are isolated. It's time to split it up into 2 equations. What is one equation I will split it up into to solve? Carl?
2x plus 7 equals 4.
Perfect. Notice, it's just the same equation without the absolute value bars. The second one's a little bit more difficult. What's the second equation I will solve? Liam?
2x plus 7.
Perfect. So here's the 2 equations. Now once you have that, you do the same 2 steps to solve because it's the same equation essentially. You subtract both sides by 7. You get 2x equals 4 minus 7 is negative 3. And then when I divide by 2, I'm going to get negative 1.5 as an answer, or negative 3 over 2, or negative 1 1/2. It's up to you how you would want to write it. I'm just going to put negative 1.5. Same 2 steps for the next one. We're going to get rid of the plus 7 by minusing 7. I get 2x equals negative 11. And I divide by 2. And negative 11 divided by 2 is going to be negative 5.5. You could also leave it as negative 11 over 2 or negative 5.5 is fine as well. So that's absolute value equations. You can have one solution, that's when it's equal to 0. You have 2 solutions, which is normal, or no solution if it's absolute value bars equal any negative number. There's 4 practice problems that I want you guys to try. For those of you here in person, I would love for you to be able to talk to each other and work these problems out together from 6 feet away. For those of you at home, if you feel comfortable, you can talk out loud. If not, that's fine. You can work independently. And I'm going to walk around and see how long it's going to take everybody, and then we'll go over these answers together once everyone here is pretty much done.